Hello, everyone. Welcome to Bucktrons podcast series and powered by Prepista, brought to you by Devistrons and Learn with Community. Thanks for joining us today. Hope you are all doing well. For those who are joining me first time, I am Aditya Sau, one of the organizer of Bucktrons 2.0 and the founder and community lead at Learn with Community. So before going to move on the topic of our today's podcast, I want to just tell you the our new folks who are joining us first time what is Buckthorns, why we are using this Buckthorns podcast everywhere. So Buckthorns as an initiative that is taken by the Davistrons and LWC communities. This will begin with a mindset of encouraging community folks and make them aware of the edtech industries by putting emphasis on problem solving, code efficiency, code optimization, and logical based programming. So we empower coders and folks to get influenced by developing software, enhancing skills, solving bugs, and producing a numerous opportunities for them via this technology. So if you haven't registered for Bucktrons, contest link in a Bucktrons discussion channel, you can go and register yourself for this contest. Now come back to the topic. So today's topic is basically on the big data. You may heard about the data science, data scientist, big data. So on a day third of Bucktrons podcast, today we have a Saurabh with us. So basically, I am thinking that lots of people has already know about the Saurabh because Saurabh is also the very you can say that the earlier member of our LWC. He has taught the data structures and algorithm in our server. He is an experienced software engineer currently employed as a lead software engineer at Impetus, and he has a hands-on professionals and managing all phases of diverse Java, big data, and has a hands-on mobile technology projects. So, hello Saurabh, how are you?
Hi Aditya. I'm good. Thank you for inviting me over here, talking to you.
How are you feeling? Like this is your first time you are giving podcast and something.
Yes. So mixed
Uh,
feeling, but I'm pretty confident because I'm happy that I will be able to help people if they want to know more because I have been hands-on in the big data world for a long time. So I hope I'll be helpful for them.
that's why we have invited you. Okay.
Yeah.
So before going to touch this big data, could you just, I have already given your introduction, but could you please give your introduction from your mouth so it will better for our
Sure.
audience?
Sure. So it's been a long time, uh, around somewhere around 11 plus years. I have been working in the software industry,
Mm-hmm.
and I have been in the phase and when in 2010 we had the buzzword Android, then we have mobile applications like iOS and all were buzzing out over there. Then in 2015 we saw that big data was a buzzword. In fact, big data is still a buzzword, but the names have changed now. Uh, Python has grown. Lots of new programming languages has. So I have seen all these phases. So pretty much worked with all of those in last few years. So yeah, this is our introduction about me. I have worked in mobile and big data uh, domain for a long time.
So how did you started your journey with big data? Like whenever this particular thought it come in your mind, ki, okay, I want to go into this field,
Yeah.
I want to enter in this big data.
Okay, so this actually started with a product. We plan to create a product. So we have a very energizing team over there at my current company.
Mm,
So since big data is a buzzword, and every company was kind of rushing towards big data. Every in you call it top fortune for if you name fortune 500 company, everyone was rushing to big data because they had their
mm,
database over there in MySQL or Postgres or some similar RDBMS relational
right.
database. They were
Mm,
kind of rushing to big data, and we tried to solve the problem because everyone was coming to because previously we were a service based company, so everyone was coming with a different problem that I want to migrate to this database. I want to migrate to some big data other database in big data. So we tried to create a platform or product which will help them migrate completely from a old database to a new modern cloud big data. So that's how we started learning new things about Hadoop, big data and all, and that's how it started.
so you didn't have any like clearly priorly mind key in from our college we have decided key okay I want to become a developer, these developer, JavaScript developer and cloud computing and I want to go in. So you didn't have it like this in your college and
Yeah, I one thing I had in mind was to work contribute to open source, work on the more on the open source tools. That's why I started
oh
on the Android part because I thought I would contribute to Android community back, open source community back.
Mm.
And the same thing started with the big data because it was also open source, so there's also a possibility of contributing back to society. So that was
O-
one
o-
motivation.
Open source is like you can say that the hub of opportunity. There you can
Yes,
get
yes,
paid. Okay,
right,
cool, cool.
right.
So, before going to touch the core topic, I wanna just know ki, as a from noob perspective, I don't know about. I don't have any idea about the big data. So, just explain the what is actually the big data and where does it come from? How does it work? In a very few simple words.
Right, right. I'll take, let's say, 2 to 5 minutes to explain it in
Ah,
a
yes,
simple
yes,
word.
yes, yes.
Yeah.
Okay, okay. Correct, correct.
Yes. So what is big data? In fact, before coming to this podcast, I was trying to collect some numbers. So numbers that I got was that in numbers I mean facts. So the fact that I got is every smartphone, in fact, every smartphone now is generating
Hmm.
40 exabytes of data per month. So
Hmm.
uh, in fact, that was surprising for me too. So what is exabyte? In fact, does anyone knows? Can they talk to us, or can they answer us in the chat somewhere? Is possibility there?
They can
Aditya?
answer in the Buckthrones discussion channel. Guys, if you
Okay,
have,
fine.
so you can answer in the Buckthrones discussion.
Right, right. So I'll leave it to you, all the audience,
Okay,
everyone
okay,
listening.
okay, okay, cool, cool.
40 bytes. Just let me know what is 40 exabytes, and in fact, just talk about what is exabytes. So when you see what is 40 exabytes, you will see that there's too much data coming in, and this this data is just for a month, just for a month. We
Correct.
could, let's talk about 5 years. If you talk about 5 years, that is around 60 months. You multiply that by 16, that is again a huge data. So there is so much data coming in. Before 2005, we didn't have such smartphones out there.
Hmm.
No such data. We had very less data out over there. So that's why we used to call it just data coming in, data coming in.
Yeah.
And it was like the data was not even useful. Let's say
Hmm.
let's say if someone gives me, I work at a hospital. Someone
Hmm.
tells me that these are the 5 reports, there are 10 reports of the person who are diagnosed with cancer. Can you design a pattern and identify any a new person coming? Can you look at this 10 patterns and tell that this person is uh, diagnosed the cancer or not? So that
Hmm.
was out of 10, just few numbers. It was not possible to identify whether this data, whether the new report coming in is is actually having cancer. So less
Hmm.
data was not at all useful out over there. So when this huge data is coming to us,
Hmm.
when there's so many reports coming to us, there are so many hospitals sending us lots of reports that this person is diagnosed with cancer, and this is reports. Our the Now when there are so petabytes, exabytes of data coming in, I'm just taking a healthcare example so that we can understand, relate
Yeah,
it
yeah,
better,
yeah.
because
Yeah.
yeah. So
Correct.
in this use case, what I'm trying to understand is when we have lots of data, and when we train our system, that if you just analyze those reports and on the data points, like doing some artificial intelligence, doing some machine learning, you can analyze that there would be faster detection for any disease. I am taking cancer here because that is also being very common nowadays.
Correct.
So
Hmm.
uh, yes, so I think, yeah, coming back to the data part. So previously it was data, and data started becoming huge. So we started
Yeah.
calling it big data, uh, and there are a few differences from data to big data. Data, uh, when we talk, in fact we will later on talk about the different
Hmm.
properties why we call it big data. Now the first most important thing is 5 V's. In fact, that calls volume. There's a volume of data,
Yeah,
variety
yeah,
of
yeah.
data. Yeah, and the last thing is value. What is the
Hmm.
value coming out of that data? So previously,
Hmm.
when I had just 5 records, there was no
Hmm.
value. In fact,
Okay.
very less value. In fact, I even can't teach you that if you look at those 5 reports, you will be able to identify that the person is diagnosed with cancer. That is very less likely. And when you see 1,000 records and 1,000 reports and analyze, you will be better be able to, in a situation, your system will be, in fact, not you. We can't recall everything. Our system will be able to understand that yes, this person is
Hmm.
possibly can be diagnosed with cancer, or in the first stage, in second stage, or any whatever whatever the terms related to the healthcare. So yeah, I think that gives you idea about what is big data, what is big data, and
So,
later on
so
I
what,
yeah,
so what I have understand ki basically you want to say ki we can say that. So maybe I'm wrong, but I'm just trying to interpret it. You have told me what I had
mhm,
basically understand ki big data is a, you can say that the combination of the large huge data, right?
right,
That
right,
present in our market, and we are used that data. You can say that the big data we are is that data we are using the projects, predictive modeling, and some you can say that the advanced analysis research sector, right?
right, right. True, true,
Okay,
right.
so that's the thing. So there
And
is
this
something
data is
you,
actually, yeah.
yeah, yeah, correct. Go ahead.
So this big data is actually giving values. That's why this data is meaningful. May call it fraud detection, call it
Hmm.
disease detection, which is a very prominent use case over there. Natural language processing. So if you there are lots of dialects, lots of accents. If you train your system on variety of accents, if you train your system on just Russian accent, your system won't
Uh,
work for the European people maybe. And if you're trained on, let's say, uh,
hmm.
1 million voice records, you are getting a better output. Your system is more better trained to handle more situation and is better used by the customers or
Uh,
end users. So big data is started
in
giving value.
you have told us basically in a few seconds about the fraud detection is very useful, right? So basically, it will just give you the, you can say that the analysis part, okay, how much fraud has done or something it will do.
Right, right.
Oh, so basically, what the basically the part of this big data into this fraud detection system? Can you just tell me?
Yes, yes, yes. Okay. So again, so let's talk about the new use case, fraud detection. In fact,
Okay.
many of you have been studying about fraud detection or have seen lots of databases on Kaggle regarding fraud
Yes,
detection.
yes. Yeah, Gal.
Yes.
Correct.
So if now let's talk about so when we again, let's coming back to the what is big data. So big data is not just one source, it is actually
Mm,
coming from variety of source. In the case of fraud detection, so let's talk about fraud detection part. So let's say you are a bank, you work for a bank, and the bank told you to there are numerous frauds happening, and people are calling and telling us that this fraud has
mm.
happened, please block my card, or my card is stolen,
Uh,
or something like that.
yes.
Yes, so now what you need to do is you are tasked to identify how the fraud is happening. So first of all, I would like to know, audience, if you have any clues, how would we be handling if you are in the place of that bank and you want to detect how the fraud is happening. I would like to know what are your approaches, because your approach could be unique too, and that could be utilized by any bank
Yeah.
or might be
Good.
by me. Yeah. So there are variety of use cases. The first is the very popular that we nowadays like Truecaller does. Truecaller identifies
Mm,
fraud as it marks someone. If someone marked it spam, and let's say 1,000 people mark it as spam, it would be already marked as spam. So
correct.
this is one kind of fraud detection that Truecaller is doing. Similar kind of data is being extracted by bank. Let's say bank would
Mm,
be going through that person's bank account, right? Bank account could be in the database, could his transactions could be stored somewhere. There could be
mm,
somewhere this person's or the customer's feedback form. It will be looking at the feedback form that is also in a structured data. It could be looking into the CRM where it the bank stored some kind of data. It would be fetching data from that too. It would also be getting data from some social media. Maybe if it has some access to that social media, maybe LinkedIn, maybe, so that it can track down that person and connect to
mm,
that person. If bank
mm,
can access that social media or Twitter or any kind of record, it can access based on location. It, let's say there is a location in not able to recall the name, is somewhere in the north Haryana, some village in the Haryana where lots of frauds happen. So identifying the patterns over there. So what I'm telling over there is we have lots of variety of data coming in from one data is coming from map, one data is showing that let's say police records of that person, one data is telling the social media of various persons or various accounts. So you are going through all this data. Or you can also take the example of stocks. Stock is even
Stocks.
a different thing. Yeah.
Hmm.
So predicting which stock will go or which stock will go down, you also need to understand market sentiments, and market sentiments can be analyzed when you go through every news, every social media post, every Twitter post, any post. So that is also you're fetching data. You need to fetch data from Nifty database, and uh, various markets. You need to fetch data from US markets and all. So you are getting data from lots of sources, and that data is in petabytes and terabytes of storage.
Yeah. So
But
can we put the, like you are saying ki, we are doing the analysis. So can I put the analysis on the decentralized network? You know ki there is an NFT you have talked about ki basically I wanna just apply this big data technique on the, not as a centralized server data. I want to
right,
just
right,
implement this whole technique in the decentralized network. So decentralized, you can say that the database. So can I apply this whole big data technique there?
right. So in fact, um, big data is a decentralized approach. We call it distributed systems. So again, an important term that I should be talking about. So it's like distributed system is actually like whenever you want to perform a task. Let's say you want to work on a 1 terabyte file.
Okay.
So again, so this is a big data use case, very popular big data use case, or
Use
in
case,
fact,
yeah.
yeah. So
Stock
you need to
market is
work on.
also using the very big use case for the
Yes,
big data because
right.
you can say that without big data we can't imagine the stock market.
Right. So let's say even in the case of US markets, there, or in the case of crypto market, there are lots large files kept on various servers, and you need to get those files. There are usually in the size of 100 GBs, terabytes and all. So you need to fetch those files, keep those files to your some kind of systems, and this could be AWS S3. You could be having your own system. But if someone has ever tried to read a 1 GB file on Notepad, someone has tried to open this kind of file.
Correct, correct. So
Your
you
system will
use the
die.
one term. Basically, you use the terms structured data. So,
Yes,
like
yeah.
as far as I know, there is a some theme. The terms is basically you can say that the master. You can say a very general term in big data, that is the structured data, semi-structured data, and unstructured data. So, what is these, like structured data? We know. What is the what
Mm.
do you like mean by this semi-structured and unstructured data?
Yes, very nice. So yeah, when we talk about, let's say, US market, let's say let's talk about health. Let's come back to healthcare. So there is various machines, imaging machines, X-ray machines. They're
Yes.
generating various logs. So logs, or let's talk about what could be structured data in the healthcare. So I can assume, let's say, an XLS bank. Sorry, the hospital could be maintaining some XLS. XLS will be always
Okay.
in the structured format, or let's say
Hmm.
the database, or their traditional MySQL, or any of the database will always in the structure. We know the structure. We just want this patient name. We just want the patient ID and his diagnosis. We don't want his address and any other details, but we don't want. We'll be fetching only those data. So that is only structured data. We just want this thing. Now this is structure. We have a structure for it, fixed structure. It has this many columns, and it will only be integer. It will only be string. Everything we know about it. Now let's talk about let's talk about semi-structured first. Semi-structured. Now semi-structured can be taken. Let's take an example of a log. You can have logs. You have any program running on the hospital, or any software program running, or any machine, any X-ray imaging machine is using any software, and it is sending logs. Logs,
Log.
log files. Yeah, log files are usually semi-structured, because on some parts it has structure, and sometimes it doesn't has a structure. So we call it semi-structured. These are actually files. Structure, it not be having same structure always. It could be varying. So we call it semi-structured. If we want to read logs, and logs are very essential because it will help us um, diagnose the issue. Maybe you may have heard about Volvo trucks send continuous logs. We in
Yeah.
various truck companies, Audi sends continuously logs to its server. So this logs is
Uh,
utilized by the machine learning system to analyze how the system should perform. So
in this call,
unstructured,
we are using logs. So can we take that thingy as a semi
yes,
structure, right?
yes. Because
Okay, okay.
semi-structured, unstructured, you do not need to analyze it further, clean it further, because you know that this will always be name let's say name should not be null, name should not be an integer, it always will be a string. So these patterns you need not apply on the structured thing, but on semi structured you may need to apply certain changes, you may need to apply some filter, or in fact this is also just a product idea. You can also create a software product which will get some log files and extract the meaningful data, on what time the log was generated, on what exactly the log is saying. So this can be a product idea which can be used by many companies. You can create a project on GitHub and sell it. Yeah, so coming to no, I think we didn't talk about unstructured thing. So unstructured
Yeah.
is any example could be your Excel report could be unstructured data because it
Mm.
doesn't have structure, but it could be meaningful somewhere when a analysis, when a system comes over here, when someone writes a utility. So I'm talking about utility because I want to you to create one so that you
Okay.
learn
I will.
and the audience too. Yeah.
Obviously. Yeah.
So yeah.
The
So
unstructured data this is. So basically, unstructured data, like basically which data part is very much higher in this market? Ki semi-structured data is present, unstructured data or structured data is basically which data part, which data category is highly present in this market? Ki unstructured data, from my perspective, I'm thinking
mhm,
ki unstructured data is very highly present in this market
right,
rather than the semi-structured and structure, right?
right. Right.
Okay.
In
So
fact, we have
basically,
lots of yeah.
yeah. Go ahead, go ahead.
So every system generates some kind of data, and it is not always in the format that we want. So we need to bring it, cleanse the data, make it
Yeah.
to that format. Like when I bring logs, I need to parse that
Hmm.
log first. I will get the log generation time. If you have
Hmm.
seen the logs, it has a start time. Then what the log is saying, what kind
Yeah.
of error is in the log. So we need to extract that into a table or uh,
Hmm.
some kind of memory so that we can analyze it further.
Okay. So there is another, like you can say that a very confusing question. Can I say that Kiki, what is the big difference, basic difference between the big data and data science? Because people are thinking
Mm.
if you are doing big data, that is equal to the data science, and
Right.
if you are doing data science, then that is also equal to the big data, for the big data. So what is the basic difference you
Right.
have feel in these two stacks?
Right. I think a very nice question, in fact. So,
Yeah.
let's take the example of YouTube now. Uh,
Okay.
so, whenever you click on some video, let's say you
Hmm.
watch a video for, let me recall some Netflix series or
Yeah.
maybe Squid Games. If you click on a trailer for Squid Games, uh,
Hmm.
and you have seen that whenever you are about to finish or you have started, you will see some recommendations out over there coming, so you can now watch some other series similar to Squid Games. If you like this, you can also like this, and those recommendations are usually personalized. So those data that is coming in, those recommendations that are coming in, that those are generated by a data science or a machine learning system. I'm calling data science over here. Data science has everything. It has AI, it has machine learning, it has various reinforced learning, it has natural language processing and various varieties. So I'm just calling it data science over here. So recommendation that you see over down there uh, is
Hmm.
is actually coming from the data science, and data
Hmm.
science team is sending this. Now it is not that it is not possible without big data, because
Okay.
uh, your every interaction, every everything that you have done, your click, you just scrolled bottom wherever you are
Hmm.
scrolling, which comment are you reading,
Hmm.
if you have uploaded certain kind of videos, all these things and more are considered. Where do you live, what is your location, which city, what language do you speak, and a more thing, what is your age group, gender, and more things like this are considered by a data science. And in fact, when we talk about big data is giving value. uh, when combine all these values, this is giving value in the form of recommendation. So a big data is giving, and the data scientist sitting over there who is using this large data set to analyze, to gain insights, to gain hidden insights and predict the future, that what this person will want, and let's present it out over there so that he doesn't leaves our app and he will stay in there. So YouTube is doing a great job out over there. Netflix also, and many other apps, and any app you see has a recommendation system out there. So every recommendation system is based on data science. So big data is being utilized by the data science team to send you certain recommendations and what you will like, or what, or generating recommendations for them, or where, which, let's say Walmart will be generating recommendations for what, in which city we should be opening more stores, which items should be kept in stock in December, which should be in January, or on weekday,
Uh,
on Monday. So certain kind of recommendations are getting generated by data science. So this is a big data is being used by data science and then generating recommendations. So it's a relation.
oh.
But when I say that, okay, I think I should make this clear, because carriers, in fact, the title over here is carriers in big data. Yeah. So when I
Correct.
say that carriers in big data, so you can become a data engineer, you can become a data scientist. Now, these two terms are two different things, because engineer is the one who is a software engineer, who is getting the data from various sources, cleaning the data, applying various utilities to parse images, parse X-rays, parse log files, and creating that data in the structured format, so that my data scientist can now read this structured format and generate recommendations. So when we talk about the carriers in the big data, you can become a data engineer who would be playing with data, generating the data, whatever data scientists want, and data scientists will then be um, playing with the structured data now, and will be generating the insights then. So two different things.
Suppose you have given me a data and I'm
Hmm.
just applying some operation on it, cleaning the data. This will come into the big data, right?
If you're up you are when you're applying some data to some kind of data, let's say you are getting continuous Twitter stream, okay, and you want to analyze which stock is going up. So you want to
Okay.
find that if Walmart stock, if someone is talking about Walmart stocks, and it
Uh,
should grow up tomorrow in the morning, or maybe in the next week. So what you are doing over here is, you need to get the data. When you are getting the data and cleaning the data, because you also need to clean the data and put that in a format. These three things: you extract the data, you pull the data from Twitter, continuously pulling the data, you clean the data and put that in your database. Let's say you have a if you're a small project, you can have a Postgres or MySQL. So you kept this data in a format. So what you did over here was, you are a data engineer. Now when this data from your Postgres is being pulled by someone else to generate, to predict the future, this is now data science. So that data scientist is now pulling your MySQL data that you have created. It's
okay.
two different parts: data engineering and data science.
So you used basically one term, that is the five V's concepts, like.
Yes, yes, yeah.
So just like cover the very quickly the what is this five V's concepts and all.
Okay, okay. So I think whenever you search for what is big data and all, you can see these five V's, because the basic
Correct.
principles. Yeah.
Correct.
So five V's, I think we have already talked about. Big data is large data. So we the first V is volume. That says large volume of data coming in. Uh,
Hmm.
let's say a hospital, if you can take examples from hospital, so it sends around 2500 exabytes of data per year. So this could be streaming, this could be any format it is sending. So
Hmm.
uh, so we have large volume, and then we have velocity. So as I told, that the data could be coming in, and if the data is coming continuously with a high velocity, as the patients are increasing, as the mobiles are increasing, as the hospitals are increasing, the data is continuously increasing, and the velocity of data is increasing. And then we have variety, and we have already talked about variety, because we take the example of healthcare. When we data was in all various format, like structured format was in XLS, unstructured was X-ray images, and semi-structured was log files. So we
Yes.
have this kind of variety of data coming in, and you need to process the data. And yeah, processing, I think I have not talked about the tools.
Yeah.
Spark is there, so yeah, we can talk about this. uh, then the third V is veracity. Veracity is about accuracy, because the data coming may not be accurate. You need to keep only the accurate data. If the patient ID or patient name is null, or patient location is null, you that data is not useful for you. So that the accuracy should be there. Your data should be trustworthy. The fifth V is value. The value that you are deriving from the data is very important, because if in the case of healthcare, you want or let's say you want to diagnose some disease, that is a value. You want to predict, you want to reduce some certain cost, you want to have certain stock prediction, any kind of prediction you are making, that is a value that you are getting from big data. So I think that covers 5 V's.
Oh, you have nicely quick covered this 5 V's. I hope so. Viewers has understand this 5 V's concept, because whenever you will be dealing with the big data, you will be getting the these first term. The You should know about the concept of 5 V's. So
Right,
what I am thinking, if you are not working in vector, you should know about this key, because data is everywhere. Without data, we can't imagine this IT industry. So
right, right.
you should know about this key volume, what is velocity, velocity. So
Right, right.
my second question is ki, there is a businesses is building up on the basis of this technology. They are providing the you can say that the services on that basis of
Mm.
this big data. They are you can say that the fundamental, the base of that whole company is depend on this technology. So why these businesses and companies are using this big data technology and these data science technology to keep their data very quick? Because if suppose we will not have this big data technology, so what will happen with our companies and businesses?
Right, right, right. So I
So,
think, yeah, we are talking about the value part, because as the data is growing, in
hmm,
fact, there are two reasons actually. So let's say, again, take example, if you are a bank, you are a bank,
hmm.
and your database was, let's say, you are in 2005, and your database is still, you are using MySQL or Postgres, or let's say,
Okay.
let's make it better, you are using Oracle.
Okay,
You're
okay.
using Oracle over there in 2005. Now
Yes.
the data suddenly is increasing, because you have opened so many branches, and so many customers are coming in there, they have so much money now. So daily the data is increasing. The previously, to generate reports, every manager, every vice president over there wanted some reports that how my
Hmm.
company is doing this month, how my company is doing this year, how my company is doing, what customer, how to attract customers, and various kind of reports. So previously there used to be one guy sitting out over there who will be writing in the Excel and and telling that boss that this is the map of the city, this is the map of the, I mean, sorry, country, and these are the spots where we are getting more customers, and we need more employees and all various kinds of reports. But since the data is growing, that person was kind of burnt out. He's like, I cannot write reports for, I cannot read about this 10,000 customers and then write back to my, then create report. So uh, so for that, an automation was needed, and the data was huge, so we need to employ certain systems. So that's why lots of systems were employed, and around big data ecosystems like Hadoop, Hive, Spark, this kind of various kinds of frameworks came to resolve the problem of that Excel guy. Then the other problem, so one problem is this: they wanted to automate when the data is coming large, and they wanted to migrate. The other problem was, let's say they have Oracle database for every transactions. Every transaction is recorded in Oracle database, but there is a limitation to our traditional databases. They if you all, I think you all know about the row. The traditional databases are usually row based. So when you
Based,
want
yeah.
to perform when you want to perform an operation, every row will be read. Okay.
Correct. Hmm.
Yeah, it goes to hard disk and read every row. That
Yes, yes,
was
yes.
kind of, and when there are, let's say, even uh, let's say 1000 GB of data, you let in, let's say, consider you have uh, let's say 1 billion records, you have 1 billion records in your Oracle table or any traditional database table, it would kind of slow down, it would be performing really slow, and you will blame it on that, since the data is huge, system is responding slow, reports are getting generating slow. So this usually happens. So that's why also they don't wanted their system to slow down, they just wanted report instantly. So
Hmm.
that's why everyone started rushing to big data, and this was the future, because they knew that everyone knew that since there is 40 exabytes of data being generated by the introduction of smartphones every month, you can see that there is lots of data coming in the next 5 years, because data will just keep on increasing. Your smart cars will be having sensors which will be sending data, your smart homes, your shoes, your watches, your this Discord voice, the voice channels and YouTube channels has lots of data coming in, and they knew that uh, when the data is so huge, because in fact, if you talk about the Google search, uh, every minute around there are 3.8 million searches in Google search. So this is just for this year. We all know that this will keep on increasing every year. So if you look, if you are a bank owner, you would be look into the future for the next 5 years. You would definitely be migrating or jumping to the big data ship.
Correct, correct. So basically, what I am thinking, ki, companies are building their whole businesses and target, because whenever we are the software engineers, and we will be just whenever we will be making the some projects and some system, so we will be taking a large amount of data. We will not prepare that system, coded that system in a way, ki, okay, this
Mhm.
system will only tackle the 2 to 3 users. We will be taking a large number of cases, and in the DSA, that's why we are using the worst case. For worst
Right.
case, how much you can say that our system will survive or will feasible, right? So that's also the case. Companies are also adopting this technology in the big database.
True. True.
And what do you think? Like you have done the, you have a basic. I can say that you have a lots of experience in this field. So, have anything you have feel in this experience because you were working from us since last, I think 2 years in this field.
Yeah, more than this actually.
More than this. Sorry, sorry. I'm
4 to 5
God.
years.
But yeah, 4 to 5 years. Oh, great. So,
Yeah.
like, what is your from your perspective? What is the pros and cons? It means advantage and disadvantages of this technology. Key advantages we have discussed, but what
Mhm.
in your perspective, in your vision, what you are thinking, what you are just seeing in the currently it's going on. Key, what is the cons of this technology?
Yeah. So cons, I think privacy. You do not have a privacy. In the when I want more comfort, and let's say I want Alexa, I want a good
Correct.
smartphone. I cannot sacrifice on. I need to sacrifice on privacy because everything on my phone, every time we call, every time we chat, is being recorded by them. So and being used as data. So this is in fact has both pros and cons. If they are using my data, they are sending me relevant content, really sending me relevant ads, relevant
They can
content.
sell your data, right, to the third party.
Yes, they could be selling my data, and it could be misused.
Yeah,
That is a
misuse.
con because yeah.
That's why
So,
the you can say that you are seeing decentralization is coming to overcome this centralized thinking, because any technology
yes,
doesn't have any, you can say that, the potential to change this technology. Now the Web3 is coming, so that I
right,
thinking ki this is the cons of every technology in Web2. Ki
right,
one party has a, you can say that, the central authority of your data, and they can do anything whatever they want with your data.
right, right.
Correct, correct. So now we are just moving, like you can say that, the pivot our whole conversation. I think, Saurabh, you have done the some work in this cloud computing sites, right?
Mm.
So how you are just relating this big data, or somewhere you can see just differentiate these things. Is the big data is related to cloud computing or not? So what's your point on this?
Yes, yes, yes,
Hmm.
yes. So I think before that we need to talk about the distributed computing a bit, because that will make sense when we are moving to cloud.
Hmm. Okay, okay.
So what we have not talked about much is why big data is a distributing computing. Big
Hmm.
data is actually a distributed computing when, let's say, when I have a 1 terabyte of file, or let's say 100 terabytes of file, um, my any of the program which is trying to read the file is will become slow. Not about I'm not talking about the notepad. I'm talking about if you have 1 terabyte of file coming from the stock market and you want to analyze this file, you what you can do is break that file into chunks. You Let's say you hire 10 machines, and each 10 machine has a program running, has the same program running, and which will analyze each chunk. So let's say um, there are around 1,000 companies data in this 1 terabyte file. So let's say
Okay.
for 10 machines, each 10 companies are sorry 100 companies are distributed to this 10 machines. Each will process. Now processing this so 1 terabyte is 100 GB, so 1000 GB. So everyone has 100 GB of data to process. Every program has 100 GB of data to process. It can even be lowered down, but let's say if my program is able to read 100 GB of data in 5 minutes. So for 10 computers parallelly running, having each 100 GB of data, everyone will be processing the data in 5 minutes, and then will be reducing that data, will be concluding that data. So I'll be getting the results. Let's say it will give me top 10 companies. We should grow up, we should go up, we should go down. So this is how this distributed computing works. So you are actually distributing your work into various chunks, and then they are sending you result back, and then you join those results and show output to the user. And when you are doing this, uh, if you are in home, or let's say you're a group of friends who have a 10 computers uh, working now. Next time when you fetch the data, you see that, oh, this is a 200 terabyte of file, and I have only tested it on 1 terabyte. I will be it will be taking hours to process this data. So now what you want is, you want some other friend to come in, and yeah, please give me some 10 machines more so that I can process the data in a faster manner.
Yeah, yeah.
This is a In fact, there could be a use case also where you just has 1 megabyte of file. One time you get 1 megabyte of file, and that can be processed by any single computer, and that is not an issue. So your other 9 machines are getting idle. So you see that when data is less, you want only one machine. When data is more, you want 20 more machines or 10 more machines to process.
Correct.
This can't be done easily, reducing and increasing number of machines, but that can be done if the machines are on cloud. So
Correct.
yeah, so if you hire only, these are kind of a load balancing thing. So when the load is more, you employ that just requires a click of if you want to increase 10 machines, you can simply by a click you can increase 10 machines, and if you decrease machines, you can decrease machines and lower the cost. So that is a clear advantage of using cloud. You can have any number of resources, not just machines. You can have any number of resources, and you can any variety. You need not install anything, everything is ready. You want a Spark or Hadoop version, the latest version, or the any other version, you can simply, by the help of a click, you can have the infrastructure set up. So cloud computing is helping us to reduce this cost in an efficient way. To If you want to reduce the machines, if you want to increase the resources, if you want to decrease the resources, if you want to have a specific configuration running for this many time. So this has in cloud computing has given an extra edge uh, in big data for my processing requirements. So this is kind of relation between my big data and cloud computing. So
Okay.
that's why everyone is now running to cloud, because loads are varying. Because in December in the US, sales really go high. In fact, in big billion sale in Flipkart, you might have heard about that. Or in the when the Hotstar aired this India Pakistan match, it had the highest number of viewers, so it had to increase its number of nodes, or nodes are actually, we call it machines. So it had to increase the number of machines, and that was possible with the help of Google Cloud, and many other clouds are there. So you can see the relation between them. So pretty much everyone is running towards cloud now.
So what I am thinking, like, can I say that big data, you can say that the something that's referred to the large sets of data, collected data, right? And
Right.
where while as well as the cloud computing, you can say that the refers to some mechanism where you are just running some operation on that big data and taking some
Mm.
virtual resources from the cloud, because you
Right.
want
True.
suppose I want to just do some operation on big data and data sets. So maybe my PC will not be able to perform these operation on this large data. So I can take the some, you can say that the PCs, and sorry, not PCs, but some virtual resources from cloud computing and perform that operation on that data set, right?
True. True. True.
Okay, cool. Now I think there's a questions from our viewer sides. They had already told us whenever the speaker will
Mhm.
come, so please ask this thing. What's your first of all? go to the roadmap, I wanna just ask you because you have already taught the data structures and algorithm in our LWC, right? So
Mhm.
what you
Yeah.
are thinking ki DSA is important. Suppose I want to become a big data engineer. So is it
Mhm.
necessary for me to know the DSA in a very advanced level or in an intermediate level or in a basic level? What's your point on this?
Yes. So DSA is must because DSA is a base. Data structure is a base for anything, and because data engineering or data scientists are all software engineers, and for any software engineering you would need the basic understanding of this concept. So data structure and algorithms are a must, which will help you. And why algorithms? Because in fact you I did not, need not tell you, already are experts in the algorithms.
Hmm.
It instead of writing a program that would take O of n square, if you write a program for O of n square in the big data world, that would be too much. That would cost you too much. That would be too heavy a program to write. If you can write a O of n or any O of log n or any other less complexity program. So obviously data structure is a must thing. DSA, in fact, including algorithms and also, is a must thing because the basics are must. And this is again a software engineering discipline. Data engineering and data science are both a software engineering discipline. So you need DSA strong.
Hmm. That the DSA is very important.
Yes, yes.
So, how you can just give the advice to our viewers, ki how they get started their journey into this big data, what they should know, what the language they should know first. So, what's your basically advice to our users? Ki what is basically I wanna just ask you the road, ki how they get
Mhm.
started in this.
Yes, yes. So I think to start into big data, the first thing you would, in fact, you can start with is HDFS. And what is HDFS is? That is actually HDFS is actually distributing this big file into small chunks, and then to write the program, there's a processing engine on big data that will process on this large chunks of data. That is called
Hmm.
Spark. You might have heard about Spark or MapReduce.
Hmm. Yes,
MapReduce is
yes.
there. These two frameworks are there. Spark is very famous and need of the industry. So Spark is a go-to framework, and programming language you should be strong. Any of the programming language you should be strong in, because Sparks, you can you have heard about PySpark, Java support, or any other program, Scala, any other programming language. Any of the programming language you are well versed with, you can start with Java Spark, or you can start that framework, Spark framework
Hmm.
with. So I think a programming language, start with the Spark, or to simpler, or to just to start, you just search how to stream uh, Twitter, how to get Twitter stream and analyze it. So you can also try that program. That is also available on GitHub. I also tried this program. So that will give you a bit insight how to run this Spark program, what are the features of so that is a small program. You just need some records, 100,000 records from Twitter, and analyze that data. So that can be a starting point right now.
Okay. So it is the basically you can say that I wanna just become the big data engineer. So we should follow these you can say stuff related to it.
Right, right, right.
Okay. So this is maybe a something personal
Mhm.
question, but yeah. So what is your basically job responsibilities as a lead software engineer at Impetus? Matlab, what's you are
Yeah.
doing in that? Hmm.
Yes, yes. So I have to deal with various. We, as I told, that we have various Fortune 500 clients. So top firms like Walmart and all are there on the list. So
Hmm.
we interact with those clients. We help them migrate to modern data warehouse. So top trending data warehouses nowadays. So when I say
Hmm.
data warehouse, you can relate it with a database. It's kind of a database.
Okay. Okay.
So modern trending data warehouses right now: Snowflake, AWS, Azure, Hive, and these are few trending databases. So daily we interact with these databases. We migrate there. They could be having any kind of workloads out over in the past. Could be Oracle, could be
Hmm.
any other ETL tool.
Hmm.
ETL is actually this process of extracting data, and transforming this whatever the data engineering part is. So there are various ETL tools like Vertica, Netezza, Teradata that are there in place. We have those clients migrate from old data warehouses to modern data warehouses. So I think this is my day-to-day job where we interact with various kinds of use cases by this various clients.
Cool. Means your response, you can say that your job responsibility is very crucial because you are dealing with
Yes,
the clients. You are just, you can say that you are interacting with the industry direct.
right,
There is no, you
right.
just the hierarchy on person. Okay. So my
Yeah,
last question. Yes, yes.
mhm. Yeah, the fun part is we are able to see their flow, how the data is flowing into the system.
Ah,
There are various banks how they want to detect frauds. There's a airline operator, a big airline operator that wants to identify that can cut cost of their flights. There are healthcare operators who want to identify diseases and various kind of operation they want to perform. So and there's prediction they want to perform. So there are lots of use cases. We have various fortune clients we have. So every time we see a new use case and every time we see a new challenge situation that is fun to solve.
so you are basically looking the problem, and you can say that the daily and day-to-day life, you are learning in this technology because you are saying you are getting challenges and some use cases. Okay, this will be become this. You can say that the product for this market and all. So learning is everywhere. I think you also learning day in a day life, day by day. You are learning in your journey into this big data. Right?
Right, right.
And so my
True.
last question to you, and thus we will just wind up the session. So how you are just looking this technology or this big data, this is basically the technology, can I say? So this, it will be a game changer, or it will just go down worse because the web3 is coming and decentralization concept is coming. So what's your point on this?
Yes, so it is still growing
Hmm.
because in every 6 months we are hearing a new product on big data. Like currently, as I told that previously there are data warehouses. Then nowadays we are seeing in search of delta lakes and whatnot. The things are still growing over here. So over for the next 5 to 10 years, big data is a place to be, and you can have a great career over here. You can, if you're itself you are a big firm, you need to migrate. You should migrate to big data, uh, as because we all know that the data would be growing. You will be having a scale of your data. If it is grows 5 terabytes, 10 terabytes, then you need to migrate to big data. So there's a lot of scope over there for next 5 to 10 years until the new things come here. But right now there is no such new thing. This field itself is evolving with various new terms coming in after every 6 months.
In decentralization, what you can do, you can just extract the data from, you can say that the blockchain, and perform the all operation whatever you want. And currently, company is doing, because without analysis, you can't say that the know your audience, know your consumer. You should have to do the some research or some operation in your data which is coming in your company or in your business, and then you can only be successful on that particular space.
True, true,
So,
true.
Saurabh, now we are on the end of the podcast. So, any last few words do you want to say our viewers?
So I have interacted with this set of group people earlier too. So I'm really happy to see these people again. In fact, not see, talk to these people and share the knowledge. And I know these people are really brilliant. So I'm really hopeful that they would be coming up with something brilliant soon. And I have tried to put on some ideas that you can, because you are creators. You are really good creators. I have already seen this, so I would be happy to see some more creations from you. And if you want to connect with me, you can directly connect with me. I would be really happy to help if you have something great in mind. In fact, I too have lots of things in mind, but I couldn't complete those parts. Commit to open source. But if you really
Ah,
want my help, I can really help you out. And anything on open source, really go for it.
we have a one community for Buckthorn Davistron. So basically, Davistron has started in the beginning on the mindset of to encouraging the people from the towards the open source. And currently, Aminos is here for the admin of this. So we will just talk on this. So guys, we this time asking us some questions. So before this, thank you very much, Saurabh, to coming this podcast. We will have some questions. If anyone, they can ask us. So thank you very much.
Thank you.
Wasn't just to stop the recording. Okay.